Node X has a TCP connection open to Y. The packets from X to Y go through an intermediate router R. Ethernet switch S is the first switch on the network path between X and R. Consider a packet sent from X to Y over this connection. Which of the following statement are true about the destination IP and MAC addresses on this packet at the time it leaves X? So see, X has a TCP connection open to node Y. This is node X. This is node Y. The packet from X to Y go through an intermediate IP router R. So R is router. Ethernet switch S is the first switch on the network path between X and R. This is Ethernet switch S. So it is asking which one is true. The destination IP address is the IP address of the R. No. R is the router. So this is not the destination IP address. The destination IP address of is the IP of Y. So this is true. This is destination. This is source. The destination MAC address is the MAC address of S. So see, S is switch, no? So in that case, switch network simply forwards the packet along the path without altering its content. So this is false. The destination MAC address is the MAC address of Y. So this is true actually. So whenever a receiving node is outside the source node's local network, in that case source node sends the packets to the default gateway, and in this case default gateway is this router. Okay, so the destination MAC address will be of that router. See question number 24. Which of the following tasks is a responsibility of the memory management unit in a system with page based memory management? So which of the following tasks are the responsibilities of the memory management unit in a system with paging based memory management? So MMU, memory management unit in the system. Allocate a new page table for newly created process. This is false because OS or kernel will provide page tables. Main memory unit, memory management unit, this will use the page table to translate virtual address into physical address of the OS. So first statement is false. B. Translate a virtual address to a physical address using a page table. This is true. Actually, this is the main functionality of main memory management unit. This will translate a virtual address to a physical address using a page table. Next, raise a trap when a virtual address is not found in the page table. This is also true because MMU will raise a trap when the valid bit set invalid. Next option, raise a trap when a process tries to write a page marked with read-only permission in the page table. So this is also true. So in this case, MMU will raise the trap when the process tries to write, but protection bit says read-only. See question number 25. Consider a process P running on a CPU Which one of or more of the following events will always trigger a context switch by the OS that results in process P moving to a non-running state, like ready or blocked? P makes a blocking system call to read a block of data from the disk. So this is true. Actually, what a process itself makes a block call. Then it will be blocked until IO operation is completed. Next option, P tries to access a page that is in the swap space, triggering a page fault. This is also true. See, if a page is not in the physical memory, then the OS invokes the page fault handler and the process remains blocked until the page is read, or that is disk IO is complete. So in this case, OS will invoke the page fault handler. And process will be in blocked state. An interrupt is raised by the disk to deliver data requested by some other process. This is false. Actually, that kind of request will be served by DMA, and the CPU does not need to get involved here. Hence, this program will use. Actually, in this case, this function is of DMA, direct memory access. Next option, and timer interrupt is raised by the hardware. So if a timer interrupt is raised, then it can be ignored. So there is no context switch. So there can be context switch by the OS in only two cases. When there is a block system call, then that process will be blocked and another process can execute. And if there is some page fault, then that process will do IO operation, and in that case context switching will be there. But for DMA operation and for timer interrupt, there is no context switch. See question number 26. Which of the following file organization is IO efficient for the scan operation in DBMS? Is IO efficient for the scan operation in DBMS? Sorted heap, unclustered tree index, clustered, unclustered hash index. So see, for a scan operation in DBMS, this sorted and heap both are IO efficient, because see, for heap file, this heap has a good storage efficiency and it supports fast scanning and insertion of records. But it is slow in searches and deletion. And sorted, there is also good storage efficiency, but here insertion and deletions of record is slow. Here search is faster. So see, in a scanning, what generally we have to see is data. in scanning. Here, search is faster for heap, for sorted, but insertion and deletion is slower. So for file organization of IO efficient of a scan operation and DBMS is sorted and heap file organization. Which of the following statement about the two-phase locking 2PL protocol is are true? 2PL permits only serializable schedules. Actually, this is true. 2PL only allows serializable schedule. In two-phase locking protocol, it ensures only conflict serializable schedules. Conflict serializable schedule. And this will not guarantee view serializability. View serializability is not guaranteed here. With 2PL, a transaction always locks the data items being read or written just before every operation and always releases the lock just after the operation. Actually, this statement is false. Locking is only in growing phase, and in shrinking phase there is no lock is gained. So there is only releasing of lock in shrinking phase. Here gain lock, and in this case release lock. So in growing phase only lock is gained. With 2PL, once a lock is released on any data item inside a transaction, no more locks on any data item can be obtained inside that transaction. So this is true. In 2PL, once lock is released, no further lock can be taken in the shrinking phase. So see, this is shrinking phase now. In this case, no lock can be gained, only lock is released in the shrinking phase of transaction. A deadlock is possible with 2PL. This is also true, as deadlock can occur in 2PL as in a schedule what two transactions can wait for each other to release the locks. That is the disadvantage of this 2PL, because they both are waiting for releasing the locks. So both are not able to complete the task. No? So in that case, there will be a deadlock. See question number 28. Which of the following statement about IPv4 fragmentation is true? The fragmentation of an IP datagram is performed only at the source of the datagram. So this statement is false, because fragmentation will be performed whenever the datagram size is greater than M2 of the network. See, if datagram size is greater than M2, then in that case fragmentation will occur. So this can be performed by the router also. So second option, the fragmentation of an IP datagram is performed at any IP router which finds the size of the datagram to be transmitted exceeds the M2. So this statement is true, because any intermediate router can do fragmentation. Next, the reassembly of the fragments is performed only at the destination of the datagram. So this statement is also true. because only whenever the packet reaches the destination, its reassembly is done. The reassembly of fragments is performed only at all intermediate routers along the path from the source of the destination. This is false because reassembly is done only at the destination. See question number 29. Which of the following statement is or false? False, we have to select. An attribute grammar is a syntax directed definition in which the functions in the semantic rules have no side effects. So what it is asking, in SDD, syntax directed definition in which the function in the semantic rules have no side effects. So see, this statement is true. What happens in syntax directed definition? A semantic rule may just evaluate a value of an attribute, or it may have some side effects such as printing values. So this is actually true statement. We have to select only false. No. What is attribute? An attribute grammar is a syntax directed definition in which the functions in the semantic rules cannot have side effects. They can only evaluate values of attributes. So this is the definition of attribute grammar actually. Next, the attributes in L attributed definition cannot always be evaluated in a depth first order. L attributes definitions is what? This can evaluate the depth first visit of the parts tree. In L attributed definition, here evaluation is done by DFS, but it is saying cannot always be evaluated in depth first order, so this is false. Synthesized attributes can be evaluated by a bottom-up parser as the input is parsed. Actually, this statement is true. Bottom-up evaluation of is attributed grammar can be done. Actually, synthesized attributes are evaluated using the attributes of only child nodes. So in bottom-up evaluation, if the attributes are maintained on the like a base do create a stack now from bottom-up parser, then the attributes of nodes higher up in the parse tree can be evaluated. Because in synthesized attributes, this is evaluated in terms of child node only. So in the stack, only lower nodes will be in low side of the stack and its parent node will be on the higher side of the stack. That means top of the stack. Actually, this is in synthesized attributes bottom up parser is used. Okay. All L attributed definition based on LR1 grammar can be evaluated using a bottom-up parser. This is false. All L attributed definition based on LR1 grammar. And this is telling bottom-up parsing. So see, using top-down parsing or just top-down, we can implement any L attributed definition based on LL1 grammar. This is actually top-down parser definition, top-down parser type, no? Top-down and bottom-up, and bottom-up using a bottom-up translation scheme, we can also implement any L attributed based on LL1 grammar. See, some LL1 grammar or some or what? Because LR1 is complete cycle now. Inside this LL1 can come. So LL1 is also possible using bottom-up parser. In addition to L attributed definition based on LL1 grammars, we can implement some of L attributed definition based on LR1 grammar using the bottom-up parser. So here it is telling evaluated using a bottom-up parser strategy. But here top-down parser can also be used for LL1 parser, and LL1 parser comes under LR1 grammar. LL1, this is LR1. We have seen the definition of top-down and bottom-up parser. In that case, LL1 will be executed using top-down parser. So this is false statement. Question 30. For the Boolean variable x, which of the following statement is false? Here false statement we have to select x into 1 x, this is true, x plus 1 x false, this should be 1, x into x 0, y will be 0, x plus x complement 1 true. So B and C option. An instruction format has the following structure: instruction number, opcode, destination register, source register 1, source register 2. So first is opcode destination register, source register 1, source register 2. Consider the following sequence of instructions to be executed in a pipeline processor. Which of the following statement is a true? There is read after write dependency on R3 between I1 and I2. I1 and I2 R3 is there, read after write. So this is reading, here it is reading. So this should be read after write dependency. There is read after write dependency on R3 between I1 and I2. So this is true. There is write after read dependency on R3 between I1 and I3. Between I1 and I3, see here write after write dependency. This is false. There is read after write dependency on R3 between I2 and I3. Read after write. No, write after read. There is write after write dependency in R3 between I3 and I4. No, there will just say I3 and I4. There is read after write dependency. This is false. So correct option is A only. Number 32. Which of the following fields of an IP header is always modified by any router before it forwards the IP packet? Source IP address, protocol, time to live, header checksum. Source IP address, why will it modified? No. Protocol, this indicates TCP or UDP. So this is not modified. Time to live, this will be modified because it will decrement by its value 1 by each router. Header checksum, TTL value is decreased and correspondingly header checksum is also calculated based on the new TTL value. This will be calculated based on new TTL. So time to live and header checksum both are modified. See question number 33. Consider the following C function definition. Int fx char star a char star b equal to a while star b plus plus return b minus a. So as you can see, b is pointing to a, and here until b is there we have to increment the value of b and then b minus a. So actually b is pointing to the location of a, and we are incrementing its location until b is there. So actually this is calculating the length of this string by b minus a. This will calculate the length of null terminated string, because this will execute until null is there. The function called f of x abcd will always return a value. Fx abcd, yes, true. Assuming a character array C is declared as char C is equal to abcd in main, the function called f of x c will always return a value. This is also true. The code of the function will not compile. This is false. Assuming a character pointer C is declared as cat star C equal to abcd, in the main the function called f of x c will always return a value. This is also true, because this is the different type of notation of only this character string. See question number 34. Let P be the partial order definition on the set 1, 2, 3, 4 as follows. P equal to x comma x. X belongs to 1, 2, 3, 4 union 1, 2, 3, 2, 3, 4. The number of total orders on 1, 2, 3, 4 that contain P is. So from 1 to 3, partial order is from 1 to 2, 3 to 2 and 3 to 4. So if we draw its hash diagram, 1 to 2, 3 to 2 and 3 to 4. So its total order. Actually, order should be followed. So it can be like this: 1. If we go from 1 to 2, then we can't come to 3 now. So 1 to 3, then 2, then 4. There is option. Because both are base cases, it should come before. And again 1, 3, 4 can also go, and then 2. If it start from 3, then 3 to 1 to 2, then 4, and then 3 to 1 to 4 and 2. Something else left. From 3, there is one more option. Because there are 2 pointers from 3 now. So 4 is not related by 1. So from 3 it can go to 4. Then 1 and then 2. See here. If we go on 2, then we are going from 1 and 3 both. Okay. So we will have to traverse both at first, 1 and 3, before reaching to 2. So see here 1 and 3 both has been traversed before reaching to 2. And from 3 and 1 also, that means 1 3 or 3 1, no issue, just order is different. But from 3 to 4 there is no need to go from 1 to 4, so it can go from 3 to 4, then 1 to 2. So how many total? 5. So total this contain 5 total orders. Question number 35. Let A be an array containing integer values. The distance of A is defined as the minimum number of elements in A that must be replaced with another integer so that the resulting array is sorted in non-decreasing order. The distance of the array. So this array has been given 2, 5, 3, 1, 4, 2, 6. Its indices I just write down 0, 2, 3, 4, 5, 6. So in non-decreasing order. So that means lowest element should be at first position. But will be sorted element. Just see 1, 2, 2, 3, 4, 5, 6. So there is no need to replace. This one also no need. So how many total? 7 are there now. So what it is asking, minimum number of elements in A that must be replaced with another integer. So see here how many swapping is there. This 5 is swapped with 2. See, 1 swapping. So 2 has come here and 5 has come here, and so just cut this one. For this 2, 1 swapping and 1. See, this 1 should come here So these two were swapped. So 2 came that time, and then 3 was swapped with 2. So total 3 swapping were there. You can see now at first 5 was swapped with 2, then 1 was swapped with 2, and then 3 was swapped with 2. Okay, so total 3 number of swappings. So the distance of the array will be 3. Question number 36. What is the output of the following C program? So see, this code has been given. We have to print int q minus p. Q minus p we can calculate from here. From here q minus p will be 1. So wherever is 1, rest will be not possible. Int star q minus star p. So star q is what? Star p will be a star a. So this is the pointer of the first element of the array, and this will be 20. And a star q will be, this is the pointer of the next element of the array, 25, because this is p plus 1. So this is pointing to first element, and a star p plus 1, this will point to next element. So next element is 25. So 25 minus 20, this will be 5. So 1 and 5, B option. Consider a single processor system with 4 processes A, B, C and D represented as given below, where for each process the given first value is its arrival time and second value is its CPU burst time. So 4 process A, B, C, D. First value is arrival time 0, 2, 4, 6, and second value is CPU burst time 10, 6, 3, 7. Which one of the following options gives the average waiting time when preemptive shortest remaining time first SRTF and non-preemptive shortage of first NP SDF CPU scheduling algorithms are applied to the process? Sorry. So at first see SRTF. At first A will start SRTF. A will go in Gantt chart. So till 0 to 2. So it will be left with 8. Then from 2 B till 4 only, no? 2 here left, so this will be 4. And then C. This is shortest, no? So this will be 0. All will be executed. So 4 plus 3, 7. Then which one is minimum? Till 7, 4. So B will be executed. 7 plus 4, 11. This will be 0. Then D. This will be executed till 18, 0. Then A till 26. Okay. So what we have to find out? Average waiting time. So waiting time for SRTF. What is waiting time? Finish time minus What's time minus arrival time? So what is finish time of A? Say 26. So 26 minus 8 plus 0, this will be 18. For B, its finish time is 11. 11 minus 8, 3. For C, finish time is 7. So its waiting time is 0. For D, its finish time is 18. 18 minus 13, 5. So how much is waiting time? 26 by 4. Is there somewhere wrong? No option is matching. 0246 0246 10637 10637. So in SRTA, what happens? Shortest remaining time first. So from A till 2, this will be 8. Okay, then B 2 to 4, this will be 4. 2 executed. 26 is total, no? 10 plus 6 16 plus 3 19 plus 7 26. Fine. Then C at 4, this is minimum, so C is finished 7. Then for D, its waiting time is 5, and for A, 26 minus 10 is 16. This should be 16. So this will be 24 by 4, 6. And for SJF, SJF is what? Non-preemptive shortest job first. So which one is shortest? At first it will come, then A will be executed at first for SJF, because this is non-preemptive, so A will be finished till 10. Okay, you mark by red. Then shortest job first till 10, all has come. Then C 13, then B 13 plus 6 19, and then D 19 plus 7 26. So what is waiting time for SJF? For A 0, for B 19 minus 8 11, for C 13 minus 7 6, and for D 26 minus 13 13. This is 17 plus 30 30 by 4, this will be 7.5. So 6 and 7.5. So option number B is the correct option. So we have to just calculate. See question number 38. Which one of the following CRDR prefixes exactly represents the range of IP addresses 10.12.2.0 to 10.12.3.255? See, 10.12.2.0. 2 octet just leave like that because both are common. 2 0 128 64 32 16 8 4 2, and this is all 0. 1 2 3 4 5 6 7 8. And next one is 10.12.3.255. 10.12.3. 2 plus 1 3 2 4 2 6 3.255. All 1 1 2 3 4 5 6 7 8. So which one of the following CRDR prefixes exactly represents this range? So see, till here all are common now. So how many bits are common? 10 dot 12 dot 2 dot 8 plus 8 plus 7 23. So this will be 23 bit. This is confirmed. So option number A is the correct answer. 10.12.2.0 and 23 bit is for network mask. This is subnet ID. Okay. Next question. You are given a set B of distinct integers. A binary search tree T is created by inserting all elements of B one by one, starting with an empty tree. The tree T follows the convention that at each node all values stored in the left subtree of the node are smaller than the value stored at the right node. So tree here left subnode, right subnode, this node will always be less than right subnode. This is of course following BST binary search tree. You are not aware of the sequence in which these values were inserted into T and you do not have access to T. Which one of the following statement is true? So this is binary search tree. In binary search tree, in order traversal is in ascending order. So this one we can do. In order traversal of T can be determined from B. See question number 40. Consider the following context-based grammar where the start symbol is S and the set of terminals is ABCD. Okay. This is LL1 grammar. Here the following is a partially filled LL1 parsing table. Okay. So for LL1 what happens? Wherever is its first, it will fill up, and wherever its first value is null, it will, that means in the first if there are terminals then it will fill up that production route, and if there are null value then it will fill the its follow value. So for S its first is, for S its first is first of A and first of B. So first of A is C and D, and if A and B are null then its first is C, D, A and B also. See, first of S can be first of A and B. So C, D, and if A and B are null then A, B. So in A, here A, this one has gone, B, from B. From C, how can it go? If A is their first value of A, so here it will go what? S to A, AB, and how will it go to D? When we have to calculate by the first of B, BB, BA. Okay, and see third option. What is first of A? C and null value. So C will go in C only. And what is follow of A? Wherever is null, then it will go in its follow. So follow of A is A and B. After A and B both are coming. So in third also A to null it will go. Wherever it's follow, all the null production will go there. So from this option you can see first option is matching S to AAB and then S to BB BA and 3 A to null here, and for B also you can find out. See, for B what is first? For B first is D and null. So what is follow of B? Follow B is a small b and a small a. So a small b and a small a, all null production will go. So here B to null. So it's matching option number A. See question number 41. Let M be a 5-state NFA with non-transitions shown in the diagram below. Which one of the following regular expressions represents the language accepted by M? So this is null transition of NFA. So this can accept empty string like null. So D option is not correct because there is no empty string it can generate. Now see, first option 002 whole star plus 1 1 to the whole star. So is it possible to generate odd number of 0? 1, 2, 3, 4. See, odd number of 0 it can generate null, then 1 0, 2 0, 3 0, then from null it will go to 5. See, from 1 to 2 null, 2 to 3 0, 3 to 2 0, and 2 to 3 also 0, and 3 to 5 null, and this is final state. So here 3 number of 0 it can generate, that means odd number of 0 it can generate. So wherever it is not generating odd number of 0, just neglect it. See, this is also generating only even number of 0, this is also only even number of 0. Here it is generating odd number of 0, so option B will be correct answer. Let's see this question. Actually, this is a very important question of this programming. Consider an array X that contains n positive integers. So this will contain n positive integer only. A subarray X is defined to be a sequence of array locations with consecutive indices. So subarray is a consecutive of consecutive elements of that array. The C code snippet given below has been written to compute the length of the longest subarray of X that contains at most 2 distinct integers. So in that subarray, maximum 2 distinct integers can be. That means element can be repeated, but distinct integers will be only 2. This code has 2 missing labeled expressions. See, P and Q. This one we have to find out. Just see, I will take one example of this array like 1 1 2 2 1 2 3 4 2. Just see for example. So what it has done, at first it has taken first equal to 0. second equal to 0. So first and second generally is for comparison. That means there are only two unique elements, no? So it will compare accordingly first and second. And length 2 is the length of the subarray. See, maximum length of the subarray we have to find out. So this length 2 will be maximum length of subarray until last second element. See, this is length of the subarray until last second unique element. Like see here how many unique elements are there? 1 1 2 2 1 2. So till here we have subarray. So its length is 336 because 3 is different, no? So 2 is maximum, 1 and 2. So here second element is 2. So its length is 3 plus 6. And len 1, we will understand what is len 1. Actually it is for just comparison. So see what it is doing. At first it is traversing inside of this for loop, and if it is first element first, so 1 is equal to 0. I just take its indices. This is 0 1 2 3 4 5 6 7 8. If I equal to 0, then our element is 1. This is not equal to either first or second, no? So in this case length 2 will be what? Actually there can be two cases. Now this is first case, no? This is for first element, so no element are present. And there can be another case like we have subarray of 1 and 2, then another element comes 3, so this will also be not present. So what will we do? We will take length 1 plus 1. In this case length 1 is equal to 0, so length 2 equal to length 1 plus 1. So here it should be length 1 plus 1. Why? Because just see here after this, and here sorry, this lane 1 will become 1, and here second it is telling will be equal to first. This is a starting index, so we are getting problem. Like, and after here max length, this will be length 2 1, and first will be xi, so this will become 1. And then again we will compare for I equal to 1, then it will be present xi equal to 1, so this is equal to first. So in this case length 2 will be 2 and length 1 will be also 2. So max length will be 2 and first is here 1. Okay, now I equal to 2, so this see, now it is not equal to first, neither equal to second. Second is what? I equal to 0, we have defined second, so initially first was 0, so initially second was 0 there. So in this case, what will happen for I equal to 2, its length 2 will be length 1 plus 1, that means 3. Because previously only 1 was coming now, so its length we have to consider. Okay, and now length 1 will become 1. Now this will show length 1, its length, that means 2's length. This will become the length of 1. Okay, and here second will become 1 first, and here max length will become 3, and first will become 2. And see, for I equal to 3, again 2. So this is again equal to what? Is there something equal to 2? Previously second was 1. Okay, so this is equal to first, no? First is equal to 2, and again this is 2. So in this case length 2 will be 4, and length 1 will become 2. So now for 2, length 1 will become 2. See, length 2 is the total length of the subarray. That means total length of the subarray is here 4 till here. But length 1 is showing current element maximum length. So current element is 2. Its maximum length is 2. Okay. And here, okay, after this max length will become 4, and first will become equal to 2. Then again I equal to 4, 1 is coming, so this is equal to second. So in this case, this length 2 will become equal to 5, and length 1 here. Now see, this is equal to second now. So in this case length 1 will become 1. This should be 1. Why? Because where we have gone, this element, no, we have gone here, and its current length is what? 1. So this will become 1, and here second will become equal to 2 first, and max length will become equal to 5, and first will become equal to what is this? 1. I equal to 4, 1. Okay, like this it will go, and for 2 I equal to 5, 2, which equal to 2, second, no? Second equal to 2 here. So again length 2 will become equal to 6, and length 1 will be 1, because again it is different, so its current index length is 1 only. That means its frequency. And here second will be first 1. Okay, so see here length 1 is showing the current element frequency, how many times it is coming, and length 2 If there is only two element, then it is just adding. Now see 3. 3 has come. So this is the special case. I equal to 6. Here just see. First will be I equal to 5, 2. I equal to 6. Its element is 3. This is neither equal to first nor second, so it will go in else condition. So here length 2 will be length 1 plus 1, that means 2. It should be 2 because there is only subarray creating 2 with 3, and length 1 will become 1, and here second will be previous first 2. Max length will be 6 only, and here first will be 3. So like this we have to compare and see the maximum length of this subarray, that is length 2. It will calculate like this. Just see its program with one example. Let's see the program I have written here. I have taken same array 1 1 2 2 1 2 3 4 2. Its length is 9. I run this code. So see its maximum length is here 6. If I just change this one with let's 5, then what should be its maximum length? Here 2 5 2 only 2 element, and 2 1 2, this is consecutive with only 2 distinct elements, so its maximum length should be 3. Just run code. See its maximum length is 3, and you can change this one 3 to 2. So what should be its maximum length? 2 to 4. Just run again. So its maximum length is here 4. So this is calculating the maximum length of the subarray with consecutive elements which have only two distinct integers. So see it has gone till last element. At first for first is generally for the current index, and ln1 we have seen current index frequency, current, that means current element frequency, and len2 is the, this is for the length of the subarray which we are calculating.